Okay, here's our review of quadratics. So parabolas, thinking about the graph, a little bit of work with some properties of the graph. This is related to factoring, if you remember, but right now we just want to look at the basics of a parabola. So I'm not going to take a lot of time to do the table of values, but essentially it looks like this. You replace the x in the equation with the x value that we're given over here. And so in this case, I'm replacing it with 0. And 0 minus 3 is negative 3. Negative 3 all squared is 9. Okay, and then the next one would be 1 minus 3, which is negative 2 squared is 4. And so I'm going to speed up this process. The next one's going to get, if you sub in and solve, it's a good skill to have, whether it's for a quadratic or anything. Subbing in and solving is a really important skill. But the next one works out to be 1, 0, 1, 4, and 9. Okay, and so we've got a list of 7 points here. And I'm just going to write them out. Again, really good review of what a point is, x and then y. And so I've got all these points that I can plot on the graph. So I'm going to go left 3. Sorry, I'm going to start at 0, 0 and 9, 1 and 4, 2 and 1, 3 and 0, 4 and 1, 5 and 4, and the last point. And then the next one over would be the next square, right? So it'd be up to 16. Like once you start seeing this pattern, start getting these points easily. But you don't have to get extra points like that. Okay, and try to connect these nicely. Nice smooth curve. And there's our parabola. So now here's what we want to worry about a little bit more. Here are the details. So I'm just going to go over them and then we're going to write them out after. So the vertex is this point here where the parabola changes direction. The x-intercept is where it crosses the x-axis. So that's actually the same in this case. Often a parabola will cross in 2 places, but this one just touches it at 1. The y-intercept is where it crosses the y-axis. The max or min, this one has a minimum because it never goes below that point. And there's the minimum. So we're going to say it's a minimum and what the value is. This opens up. And the equation of the axis of symmetry is where you draw a line through the vertex so that it's symmetrical on both sides across that line. Okay, so the vertex is a point. So it's the point 3, 0, over 3, up 0. The x-intercepts, again, there's only one, and it occurs at 3, 0. You could also just list the x part of that. So we could just call it 3. The y-intercept occurs at 9. So that's 0, 9. The max min is a minimum of 0. That's the y value that it never goes below. So it's the minimum value. The direction of opening is up, and the equation of axis symmetry, this is a tricky one, but it's x equals 3. Because it's an equation, I've got to have the equal sign in there. It's got to look like an equation, kind of like an equation, y equals mx plus b, but because it's a vertical line, it's a little bit different. So x equals 3. Just try to remember, for equation of the axis symmetry, put an x equals in front of it, and then it's the value that you draw a line through the x value there of the vertex like that. Okay, so those are the important properties, really what define a parabola. And we did some applications and we looked at how those properties are often the answers to questions about real life problems. I don't have a lot of room here to answer these, but normally you'd have a bit more room. And so remember, we use technology to graph this, but you won't have that on the exam. So if a question like this came up, it would give you the graph. And when I look at this, this is the graph of that quadratic equation. Okay, and so coin is tossed, and h, which this should be h here, is the height of the coin, and d, this is a horizontal distance of the coin. So somebody's tossed a coin. So you think about where it's tossed at distance 0. That's where it's tossed from. It hits a maximum height and then falls and hits the ground. And it obviously wouldn't actually go below the ground. So this part of the parabola, that part makes sense in math, but it wouldn't be true in the real world. Same with this part here. It doesn't actually exist in the real world, so that's where we're interpreting the answers for this. So for part A, what was the starting height of the coin? It says h is the height of the coin in feet, so 4 feet. Don't just say 4, include units. What was the maximum height of the coin? Looks like about 5 feet. If it wasn't right on, then I would estimate, but that looks like it's right on. How far did the coin travel before it hit the ground? So it started at 0 and it went all the way, looks like, to 6 feet. So 6 feet. And draw a sketch. Ooh, I really don't have space for this, but a sketch looks like this. There's already a graph, so it seems weird to draw a sketch, but remember, a sketch looks like this, and I just draw the real life part. So the if I was doing this on a computer, or if I have the graph, this is the whole parabola. But what we want to do for the sketch is just the real life part. So that is 5 feet. This is 4 feet, and I'm going to label these parts, and this is 6 feet across. Right? So I labeled the important points, and I just drew a sketch of the real life part. That's an application of quadratics. Determine the zeros. So this looks like something that was factored. It could have started like this: x squared minus x minus 6. Two numbers that multiply to 6 and have a difference of 1. So -3 and +2 would qualify for that. And it says determine. So we did questions like this where it gave you this. You had to factor it first and then answer where the x-intercepts are. This one just gives us the factored form, and we can say what the x-intercepts are. So remember, the trick is you change the sign from what's inside the brackets. So 3, 0, and -2, 0. Really easy, but very specific. You just have to remember it. And if you do, you change the sign and you just list them. Okay, and I think this is the last part. The next part's the review. So use first and second differences to determine if the following table shows a relation that's linear, quadratic, or neither. So what is first and second differences? Well, I look at the change that goes here. So from 0 to 1 is up 1. From 1 to 4 is up 3. From 4 to 9 is up 5. And from 9 to 16 is up 7. And if the numbers are negative or if they jump around a little bit, it can be a little bit harder to figure this out, but you're thinking about the change from one value to the next. Okay, always going down the list. And make sure you get the sign right? Whether it's going up or down. Is the number getting bigger or smaller? And if these were all the same, then this would be a linear relation. That's what first differences show me. The first time doing this is called first differences. And if they're all the same, if they were all 1, 1, 1, 1, 1, it would be linear. They are not all 1, so it's not linear. So I'm going to do the process over again. And 1 to 3 is up 2. 3 to 5 is up 2. 5 to 7 is up 2. And look at that. Those are all the same. The second differences are the same. That means, therefore, this is a quadratic relationship. Remember, if the first differences were the same, it would be linear. If the second differences are the same, it's quadratic. If neither is the same, then it's neither. It might be something else, but we don't know. Okay? And that's a quick review of parabolas and quadratics. Remember, it's related to factoring, but it's important to go back and practice the properties because that's what we haven't seen in a little while.